any way we want, right? Once we put a grid through it, we can create as many triangles as we want. That's how I like to do it, right? I like to make triangles because triangles are easy to... Anyone who does math likes triangles easier than squares. It's obviously 3 is easier than 4 movements, right? Now, from this factor, right, we have an applicator from a constant standpoint. These are both constants. Speed of light and the constant are both the same thing, in a way, right? But now we can we can put cobalt 60 here, right? And we can put this constant whatever we want in its laws of physics, right? In reality, right? So now, no more do we have energy, because energy already equals energy, right? We have energy equals A plus B. Boom. Right? Because, for this particular scenario, we call it A plus B. But technically, it would be... Right? Sorry. It might even be squared, right, at this point. Which is still really good, because we can plus, times, or divide, multiply, whatever. We can do whatever we want within this sequence still, right? Because we have now, with basic chemistry, we've been able to even balance it on both sides. Because this is what all of this process accommodates, in a way, right? Because that's just how it works, right? Within a system. Now, we can apply in this structure, in this formality. We can make this equation as far as we want. But the fact is that once we apply it to this section here, or once we apply Einstein to it in general, the job is done, right? We now have a factor of equations in which we have applicators that leaves room for us to fuck around, right? In reality, right?
Appropriate way to be doing science?
Well, I would say it's not really
It's an appropriate
going
way to
against the
do
grain
math.
of what we always do. It's more that the time scales involved for being able to check the mathematical predictions are much longer. Even in this case, we don't know how long they will be compared to things in the past. So take Einstein and his special theory of relativity. There was a real puzzle that he faced, which had to do with properties of light and its motion. He wrote down some mathematical ideas just out of his head and thinking about the data and the situation. And very quickly, those ideas could be tested. In the general theory of relativity, 10 years later, he